Wasting even a few inches of wood can cost a sawmill millions of dollars every year. That's why today's most advanced mills rely on powerful 3D scanning systems and fully automated saw lines to maximize every cut. So, how do they process thousands of logs every day while generating almost zero waste? Welcome to RaWMachines. Let's find out. In the biting winter cold, while the ground is still covered in snow and ice, the loggers are already starting their day. To get the job done, the Cat 550 harvester rolls onto the site. Engineered to operate under the harshest conditions, this machine can clamp onto a trunk, fell it, delimb it, and cut it into logs with near-perfect precision. But the work doesn't stop there. As soon as the tree hits the ground, a system of feed rollers pulls it through the cutting head, stripping off the branches while electronic sensors measure its length. The onboard computer calculates every meter of timber, bucking it into precise lengths required by the mill. In less than a minute, a tree that once stood tall in the forest is transformed into neatly processed logs, ready for the next stage of the journey. But there's a catch. These logs are still buried deep in the forest, in an area completely inaccessible to trucks. So, how do you haul tens of tons of timber out of here? The answer lies in the Cat forwarder. If the harvester is the powerhouse of timber harvesting, the forwarder is the backbone that moves the entire forest. No asphalt, no smooth pavement. Only mud, snow, rocks, and constantly shifting slopes. This is the exact environment this machine was built to conquer. The hydraulic crane continuously grabs logs and loads them into the rear bunk. Once fully loaded, the machine slowly makes its way toward the staging area. Here, the journey of these logs enters a new phase. A log loader equipped with a massive crane arm gets to work. Bundle by bundle, the timber is lifted off the ground and placed onto the truck's trailer with pinpoint precision. It might sound simple, but every single grab is a balancing act of weight and stability. One poorly distributed load, and the long haul ahead could become far more dangerous. With the final chain cinched down tight, the Scania slowly pulls away from the staging area. Behind it lies tens of tons of timber, preparing for the longest leg of the journey. Forestry roads are rarely smooth. They are narrow, winding, and constantly changing in the elevation, especially through the hairpin turns, where the driver has to calculate every single inch when maneuvering the wheel. Carrying tens of tons in tow, every movement must be executed with absolute precision. Enter a curve too fast, and the load could shift. Brake too hard, and the truck's momentum changes instantly. On roads like these, a driver's experience and cool head are often far more critical than the sheer horsepower under the hood. After hours of navigating dense forests, steep climbs, and countless treacherous turns, the final destination finally comes into view: the Weyerhaeuser mill. Founded in 1900 by Weyerhaeuser, this mill has evolved through generations of modernizations to become one of the most advanced wood processing facilities in the United States. The primary raw material processed here is Douglas fir, a wood species revered in America as a symbol of strength and durability. Interestingly enough, the logs aren't sent straight to the production line upon arrival. Instead, they are dumped into the mill's vast mill pond. At first glance, this might seem odd. Why soak the timber in water instead of processing it right away? The answer lies in the very structure of the wood itself. If left exposed to the open air for too long, the logs gradually lose moisture, making them prone to cracking and reducing their value as raw material. The pond helps maintain their natural moisture content, while doubling as a massive storage yard, ready to supply the production line at a moment's notice. When their turn comes, the logs are hauled up onto the conveyor belt one by one, and from this point on, every single decision is left to the computer. A series of high-speed laser scanners continuously sweeps across the entire surface of the log, recording its diameter, curvature, shape, and even the natural defects hidden beneath the bark. In just a matter of seconds, the computer generates a complete 3D model and calculates the optimal cutting plan. Every decision made at this stage aims to squeeze maximum value out of every single inch of timber. Next, the log feeds into the debarker. High-speed serrated steel wheels continuously strike the surface, stripping away the outer bark with virtually no damage to the wood underneath. The bark, seemingly worthless, doesn't go to waste either. It is collected and ground into mulch, or used as fuel for biomass boilers, powering the mill itself with heat. At Weyerhaeuser, almost no part of the tree goes unused. Next, the logs move to the primary breakdown area. Here, the buck saw cuts the round wood into predetermined lengths. The RaWMachines kicker system then automatically sorts each log based on its small end diameter and routes it to the designated deck. The RaWMachines operator uses a grapple to remove broken logs while aligning the remaining ones to keep them straight, setting them up seamlessly for the next stage of processing. If the laser scanning system is the brain, then the primary sawmill is the beating heart of the plant. First, each log is scanned once more by a 3D system to determine the optimal cutting orientation. A log turner automatically rotates the timber into precise position before the side chipping heads and profiling heads square off all four sides, transforming the round log into a squared timber known as a cant. The cant then moves into the gang saw, where dozens of blades operate simultaneously to break it down into multiple boards in a single pass. Sensors continuously monitor blade vibration and alignment, making automatic adjustments if any drift is detected to ensure absolute precision. The freshly sawn boards then pass through an edger to trim away uneven edges, followed by the trimmer saw, which cuts them into standardized lengths. Meanwhile, an array of sensors detects dead knots and cracks to calculate the smartest cut points, salvaging the maximum amount of high-value lumber. In just a matter of minutes, a round log is transformed into dozens of boards, ready for the grading and quality control stage. Here, every single board undergoes a rigorous quality control process. High-speed camera systems and moisture sensors continuously scan the surface to detect knots, cracks, warping, and other defects. Based on the gathered data, the computer automatically sorts the lumber into different quality grades. For premium-grade lots, quality inspectors still perform manual spot checks to ensure every product strictly meets standards. Finally, the lumber travels to the stacker, where it is neatly bundled into units before forklifts transport them to the GIP storage yard, awaiting final finishing. If the previous stages focused on shaping the frame of the board, the planing and finishing process is where it gets its flawless skin. Rough lumber units from the GIP yard are fed into the planer by forklifts at a mind-boggling speed, 2,400 feet per minute. Amid the sharp scream of steel blades, the rough sawn surface is rapidly transformed into silk-smooth wood with crisp, clean edges. After planing, there is zero room for error. The Lucidine scanner scans for surface quality, while the warp tunnel system strictly checks for any bowing or twisting. At the grading table, even the slightest defects are marked for the planer trimmer to cut away, boosting the commercial value of the remaining wood. Any trimmed offcuts are collected by the recirculation system and fed right back into the line. Finally, the stamp reader verifies the quality and applies the grade stamp to each board, Weyerhaeuser's official seal of quality, before the product leaves the mill. The transformation journey at Cottage Grove comes to a close as the boards reach their ultimate finish. This is the stage of order and precision, where the products of the deep forest prepare to step into human life. To prepare for the long haul ahead, the lumber units enter a hydraulic press to be squared up with total perfection before being bound tightly with steel strapping. Each unit is sprayed with a protective moisture barrier coating, while robotic labelers apply barcode tags for full identification. Every unit now carries its own digital ID card containing comprehensive data on wood species, quality grade, and production timestamp. Inside the warehouse, the FIFO rule, first in, first out, is strictly enforced to keep inventory moving seamlessly. Forklifts operate in smooth rhythm, loading the lumber onto rail cars or flatbed trucks to be dispatched to construction sites across America. As those trains roll out, it's more than just building materials being transported. It's the passing of a legacy that has been in motion for over 120 years, bringing the power of Oregon's old-growth forests to the homes of tomorrow. Leaving Oregon behind, our journey takes us to northwestern Montana, a land of majestic mountain ranges, freezing winters, and endless stretches of forest. This is where Plum Creek manages hundreds of thousands of acres of timberland, home to a diverse mix of species like lodgepole pine, larch, spruce, and Douglas fir. This rich variety of raw material allows the mill to operate year-round while producing a wide range of products for the construction industry. Unlike traditional sawmills that yield solid dimensional lumber, Plum Creek takes a different path. Here, logs are peeled into thin layers of veneer, then bonded together to manufacture engineered plywood, a material renowned for its high strength, dimensional stability, and superior load-bearing capacity. The first stage takes place in the debarking and conditioning plant. The logs are soaked in hot water at 170 degrees Fahrenheit for 12 hours to soften the wood grain structure. This conditioning process allows the lathe to peel away thin layers of veneer with ease, yielding a smooth and uniform surface. Once the logs reach the ideal softness, they are fed into the veneer lathe. The blade turns counter to the spindle, working in tandem with a laser alignment system precise down to the micrometer. With every rotation, a silk-thin ribbon of wood is effortlessly peeled away, wrapping around the spindle before gently laying down onto the conveyor line. Leaving the lathe, the continuous ribbons of veneer feed into the clipper, where defects are trimmed away and the sheets are neatly cut to standard dimensions. Full-size sheets move to the stacking area, designated to become the face, back, or core layers of the plywood. Smaller pieces are sorted separately, while damaged fragments or strips narrower than 8 inches are chipped down to be recycled into MDF. Next, the veneer enters a multi-zone drying system. Drying temperatures and line speeds are fine-tuned based on wood species and sheet thickness, ensuring moisture evaporates evenly to prevent warping or splitting. After drying, each veneer sheet undergoes another inspection to identify and repair any remaining defects. Small knot holes are automatically repaired on the plug line, where wood plugs with closely matching color and grain are inserted to restore the surface almost seamlessly. Short or reusable veneer pieces are then joined together by the composer, creating new core veneer sheets. By making use of materials that might otherwise be discarded, the mill not only reduces waste, but also maximizes the value extracted from every single log. Once all the veneer sheets are ready, they are transferred to the layup line. Here, each veneer sheet is coated with adhesive and carefully stacked with alternating grain directions. This cross-grain construction gives plywood exceptional dimensional stability, making it far less prone to warping while providing significantly greater strength than solid wood. The entire veneer assembly is then placed into a hot press at approximately 255 degrees Fahrenheit for nearly 5 minutes under pressures of several hundred pounds per square inch. The heat and pressure cure the adhesive, permanently bonding the veneer layers into a single, finished sheet of plywood with the strength and integrity of one solid panel. Leaving the press, the panels still undergo one final finishing step. Minor surface defects are filled with specialized putty, while larger cracks or voids are routed out and patched with polyepoxy plugs to restore structural strength and appearance. The panels are then trimmed to size and sanded to a smooth finish, before receiving a final grade inspection and being stacked for shipping. What truly defines Plum Creek's value isn't just its high-quality plywood, it's how they manage the forest resource itself. Every harvested tree is part of a long-term reforestation plan, preserving the delicate balance between production and conservation. From the main log to small veneer cutoffs and residual wood, virtually every piece is put to meaningful use. This has been Plum Creek's guiding philosophy for decades. Harvest responsibly, utilize efficiently, and give the forest the opportunity to thrive once again. We take, but we also give back. Plum Creek doesn't just manufacture materials, they nourish the future of wood and the future of sustainability. Leaving the plywood plant behind, our journey takes us to the New Bright Mill, where timber is transformed into dimensional lumber and wood components for construction, framing, and interior design. Gone are the veneer peeling and multi-layer pressing stages. The production line here zeroes in on a different objective, turning each log into high-precision products while extracting maximum value from every single grain of wood. Every day, hundreds of logs arrive at the mill's log yard by truck. Right from the start, they are sorted by size, straightness, and overall quality. Large, low-defect logs are prioritized for structural products, while smaller ones are directed to the appropriate processing lines. Sorting early on optimizes efficiency across the entire system, while keeping material waste to an absolute minimum. As the round logs enter the production line, the saw blades cut along pre-calculated paths. The objective is to maximize yield, produce boards of standard dimensions, and minimize disruption to the wood grain structure. Immediately following, a continuous conveyor system catches each board, guiding it to the next processing stages while aligning its position, dampening vibration, and ensuring every single board stays perfectly on track. After being kiln-dried to the target moisture content, the boards pass through planers, rotating drums, and sanding belts to eliminate minor ridges, smooth the surfaces, and prepare them for downstream processing like coating, veneering, or joining. All along the line, continuous sensors measure the thickness and flatness of each individual board. In parallel, operators perform manual inspections on critical products to catch any subtle defects the automated system might miss. Thanks to these multiple quality checkpoints, product standards remain consistently high before moving to the packaging area. One of the standout features of the new Bright Mill is its closed-loop biomass energy system. Two 3-megawatt biomass boilers burn tree bark and wood chips generated during production to supply heat for the dry kilns and facility operations. As a result, wood byproducts never become waste, but are continuously converted into an energy source to power the mill. In the final stage, qualifying boards are sorted by size and grade before being neatly stacked. They are then strapped into bundles, ready to be moved to the warehouse or shipped to customers. New Bright may not be wrapped in iconic stories of sustainable forestry or eco-certifications. Yet mills like this are the indispensable links that keep the global timber supply chain running smoothly, day in and day out. The final stop on our journey brings us to Fort William, a modern wood processing facility where automation and human expertise work hand in hand to deliver consistent quality. While the previous mills focused on extracting maximum value from every log, Fort William takes charge of the finishing stages, ensuring each piece of wood meets the exact requirements of its intended application before reaching the customer. From the very beginning of the production line, the tandem infeed system continuously feeds multiple logs into the process at the same time while maintaining precise spacing and positioning for each one. This consistent material flow allows the entire line to operate at high speed, minimizes collisions, and ensures every log is processed according to its designated specifications. Next, the logs pass through a series of specialized sawing systems. Depending on the characteristics of each log and the customer's order requirements, the machines perform ripping, cross-cutting, edge trimming, and precision sizing. In just a matter of minutes, the original round logs are transformed into framing lumber, flooring boards, or engineered wood panels with exceptional accuracy. Behind this impressive speed is the seamless coordination between advanced machinery and skilled personnel. Inside the control room, engineers monitor the entire production line through a centralized control system, continuously fine-tuning machine settings based on the moisture content, density, and actual quality of each batch of timber. At the same time, an array of automated sensors constantly measures the thickness, straightness, curvature, and surface quality of every board as it moves along the conveyor system. Even with today's advanced technology, however, human expertise remains indispensable. At critical inspection points, experienced operators carefully examine each board, identifying subtle defects that automated systems may occasionally overlook. Products that fail to meet quality standards are automatically diverted for reprocessing or rejection, while approved boards continue to the finishing stage. After sanding and a final quality inspection, every product is sorted according to its dimensions, quality grade, and intended application. Some are transferred to specialized processing lines for customer-specific finishing, such as surface coating or other custom treatments, while the rest are bundled, packaged, and moved into the finished goods warehouse. This marks the final stage of the manufacturing journey. From trees that once stood quietly in the forest, through dozens of processing steps and the coordinated efforts of hundreds of machines and skilled workers, the wood is now ready to leave the factory and become part of homes, bridges, and countless other structures around the world. So, we have reached the end of a long journey, a tree's journey from a frozen forest to some of the most advanced production lines in the world. We followed loggers into the harsh winter cold, witnessed harvester machines bring down trees with incredible precision, and saw rugged forwarders conquer mud, snow, and treacherous terrain to haul timber out of the woods. From logging trucks carrying tens of tons of timber across forest roads, we moved on to explore factories where lasers, sensors, and automated assembly lines work tirelessly to turn rough logs into valuable products that serve our everyday lives. But perhaps the most incredible part isn't the sheer scale of the machines. It's how humans have learned to harvest resources so intelligently. Every cut is calculated to maximize yield. Every log is selected for its exact purpose, and virtually no part of the tree goes to waste. That's why modern forestry is no longer just about felling trees. Behind every harvested log lies a forest management system decades in the making, from planning and nurturing to selective logging, replanting, and ecosystem restoration. Technology doesn't just help factories produce faster or more efficiently, it helps us make wiser use of what nature took so long to create. Perhaps after this journey, we'll no longer look at a piece of wood as just another familiar building material. Behind those natural grain patterns are decades of growth deep in the forest, the dedication of forestry workers, the expertise of transport drivers, the meticulous skill of engineers, and the power of hundreds of modern machines working in perfect harmony to create an almost flawless production chain. And that highlights a fascinating paradox. A tree's value doesn't end when it's cut down. On the contrary, that's when a whole new journey begins. A journey where nature, humans, and technology come together to build homes, bridges, structures, and countless products that will remain part of our lives for decades to come. Thank you for joining RaWMachines on this journey of discovery. If you enjoy documentaries about machinery, technology, and modern manufacturing processes, don't forget to subscribe to the channel so you won't miss our upcoming episodes.